All right, welcome to Module 2 of EE221 Circuits 2. This module is called Frequency Response and Filters, and that's exactly what we're going to talk about in this module. Of course, I'm going to do an overview of the topics that we're going to cover in this module, starting with transfer functions. So you've actually already seen transfer functions sort of when we did voltage dividers and current dividers, but you probably just didn't notice it. So I'm going to go through some examples and talk about transfer functions, show you how to derive them and why they're important. Then we're going to get into frequency response, which is basically plotting the behavior of a circuit as the input signal frequency changes. So up to this point, we've kind of been working with sinusoidal steady state. We've been working with a single frequency. We could extract that frequency abstract away that frequency and just work with the magnitude and the phase of a phasor and solve our circuit that way. But now what we're going to do is we're going to say what happens if that frequency that we had fixed at some particular frequency, if we let that frequency vary, how is our circuit going to respond? And so that's what we're going to do when we talk about frequency response. And the transfer functions that we're going to learn about first are going to be very useful in helping us determine the behavior of the system or the circuit over the broad range of frequencies that we're interested in. Okay, then we're going to move into Bode plots, which are basically just the industry standard way of sketching these plots. So we're going to, again, like I said, plot basically the frequency dependent behavior of these circuits and systems one particular way, and then we're going to learn the standard way of doing it, which is plotting them using Bode plots, which is basically just an easier way to sketch these plots, which are very accurate and very good approximations for these plots, but they're much easier to draw than going point by point and frequency by frequency. So you'll see when we get to Bode plots what that's all about. We're going to do a little bit of a review of logarithms and what a logarithmic function and logarithmic plots look like as opposed to linear functions and linear plots, because those are relevant to Bode plots. And then the last thing that we're going to do is we're going to look at different types of filters, circuits that basically filter out certain frequency bands or certain ranges of frequencies and then allow other ranges of frequencies to pass through unaffected. And so there's such a thing as passive filters, which don't include any active components like op amps or transistors. And then there's active filters, which do include op amps and transistors. And then we'll look at some design problems. I kind of have these out of order because I do passive filter design problems here, and then I introduce active filters at the end. But nonetheless, that's kind of the overview of Module 2. And so without any further delay, let's get right into it. And go ahead and end this video, and then we'll get right into transfer functions in the next video.